So let's talk about reach. So reach is a stream segment element that transforms the inflow hydrograph from the upstream end of a stream reach into the outflow hydrograph at the downstream end. So if we look at this two subbasins here, okay, so there's like one subbasin up here and then another subbasin down here like this, right? And so when we say reach is a stream segment element that transforms the inflow hydrograph, so at the outlet point of this upper subbasin, we have a hydrograph, right? We have the discharge hydrograph. And then at the outlet of this lower subbasin, we have another discharge hydrograph. So we have inflow hydrograph that happens at the outlet of this first subbasin, and then from the upstream, and then we have the outflow hydrograph at the downstream end, like right here. Okay, so that's what it means. So this area in the box, so this right here, like that's a reach. Okay, I know there are these other reaches as well. Okay, but we are mostly concerned with this main one in the middle because this other channels flow into this main reach anyways. Okay, so this is called a reach. Okay, so let's talk about reservoir next. So reservoir is a stream element that applies the inflow hydrograph to a reservoir and generates an outflow hydrograph, functionally similar to a reach but represents storage effects. So this is like an example of, let me switch here. So this is an example of a reservoir right here, right? So we have a water that's right here, and then a reservoir, so like a structure like this, will block it from flowing to the other side. And this is called, so basically this like area, or in this area, they're called, or I guess this area on the left is called the reservoir. Okay, so if you see the illustration below, we have a discharge hydrograph down here. Okay, and then we have the water flowing in, and then normally the discharge hydrograph should look like this. It looks sharp, but then because there's a reservoir blocking the inflow, now it looks like this. Okay, the discharge that was supposed to happen has been blocked by the reservoir, or has been slowed down by a reservoir. So now the outflow hydrograph looks like that. Okay, so again, reservoir is an element that applies the inflow hydrograph to a reservoir and generates an outflow hydrograph. It's similar to a reach, but it has storage effects. So when we say storage, it means something that's getting stored, right? So instead of water just flowing like that, at every certain time period, instead of flowing continuously, it gets stopped. It gets stored in these specific time periods. Do you get what I'm saying? So from 0 second to 1 second, 2 second, instead of flowing all the way from 0 to 2, in every certain period of time, it gets stored. It gets attenuated, so it gets delayed to reach the next point. Okay, instead of flowing continuously like this. So that's what we're saying when we're talking about storage effect. Okay. So next is junction. So this one's very simple. It's a point where two or more inflow hydrographs combine to single outflow hydrograph. So if you remember, when we have a basin and then like sub basins, mostly like the rivers flow in to this main channel like this, right? So we have inflow 1, inflow 2, just like how it is with the basin, and then it reaches this one point, and then it becomes this one big outflow, right? That's what junction is, this point where two or more inflow hydrographs combine to single one. And then we have diversion. So this is the opposite of junction. So instead of coming to this one point and becoming one, it's a point where part of the flow is diverted away. So instead of this, now we have this point where inflow gets split into like two outflows. So main channel outflow, secondary channel outflow. Okay, let's talk about source and sink next. So source in the HEC HMS looks like this, and it adds water to an element. So it's basically a source of water, where it comes from. And then we have a sink. It looks like this in HEC HMS, and it drains an element, and it basically works as a watershed outlet. Okay, so if you look at the image on the right here, we have this different subbasins, right? And then we have a sink, like at the end, right there. So all the water flow, all the stream flow, goes into this like one outlet at the end, and we call that element sink. And that's what we use in HEC HMS to show an outlet. Okay. And then so we have like subbasin in HEC HMS. It looks like this. That converts rainfall hydrograph into runoff hydrograph. Again, reach, we cover that. So that routes runoff hydrograph from one place to another. And then we have a reservoir that simulates a reservoir. Junction connects elements, and then diversion, diverse water from an element. We covered all these things because like these are the elements that we use in HEC HMS, and the icons look like them. Okay. And then there are some HEC HMS methods. So when we say HEC HMS methods, it means different kinds of methods that can be used for different part of the rainfall runoff model. Okay. So for loss part of the rainfall runoff model, we have these. And then for transform, we have these different type of methods. For base flow, we have these. Routing, we have these. Precipitation, we have these. Okay. You just have to know that there are these different type of methods, and then depending on which method I tell you to use, the result will differ. So this is the rainfall runoff like workflow basically. So we have the precipitation model first, and then we have loss computation, and we get loss using one of these loss methods, right? And then we have excess precipitation transformation, and then we have the addition of base flow, and then we get total subbasin runoff. So again, loss is the part of the rainfall precipitation that's doesn't make it to the ground, so it gets just lost. So it doesn't make it to the ground. It gets blocked by like a tree or a building, and also it could be some precipitation that just evaporates right away. And so whatever precipitation that makes it to the ground, that becomes excess precipitation. And then whatever water that eventually makes it to the water table and goes below the water table and flows on the ground, that's base flow. So combining the excess precipitation with base flow, we get total subbasin runoff, and then from that we get flood routing, and then from that we get outlet flow. So that's the whole process. So direct runoff, we have gauge watershed, and then from gauges we build a unit hydrograph. So a gauge is basically water level station where they measure so how much water is rising in the area. So it could be like a bridge. So if we have a bridge, there will be these markers that measures the water level. And then from the water level, we can convert that into stream flow, and then from that we get a unit hydrograph. Okay, so when we say gauged watershed, it means we have these gauges, whether it's like part of a bridge or maybe it's some gauging device that measures, the water level, or sometimes they measure the flow directly using a device. Okay, they do that too. So we have some type of gauge, whether it's this or this. Okay, so gauged watershed. So ungauged watershed, we don't have any of these, so we have nothing. Okay, so in that case we have to use synthetic unit hydrograph. So we have to use a unit hydrograph that can be made by using some mathematical methods. Okay, so it's not natural, it's made up. So that's why it's called synthetic. Okay, so for synthetic unit hydrograph, we have a Snyder synthetic unit hydrograph, or SCS synthetic unit hydrograph, which is called dimensionless unit hydrograph. Okay, and then next, so all the direct runoff part we just covered. So now we have flood routing part. So when it comes to flood routing, if there's a reservoir, we're gonna have to do reservoir routing. And for that, we'll be using modified pulse method. For channel routing, so that's a channel like this from one outlet to the other, right? This part channel. For that routing, we'll be using Muskingum. And then for the watershed routing, we'll be using Clark. So the routing of like the entire watershed. So for hydraulic flood routing, we use kinematic wave approximation or Muskingum-Kunz method. Okay. So this is type of results we can get with HEC HMS. So we get these subbasins, and for each subbasin we can get parameters like times of concentration or R. I'm not too sure what this stands for, but yeah, and then SCS curve number, impervious area percentage, and then the area of each subbasin, right? So we have input unit hydrograph for subbasin 3. We have Muskingum coefficients. We have a hydrograph, a table with time, and then some data like this, right? So for watershed like this, we can get all these different type of datas using HEC HMS. And that's the end of the lecture. Thank you for watching, and I'll see you in the exercise part of the class.